Student, today we start haloalkanes and haloarenes. This is our first chapter. What is haloalkanes? Listen, all of you know what is alkane. They have general formula CnH2n plus 2. For example, CH4 C2H6. Here n equal to 2 into 2 4 plus 2 6. Clear? So how will we get alkane? Simply, so what we have to do, we have to subtract one hydrogen. Means if this methane contains 4 hydrogen, we have to subtract one hydrogen. Then now how many hydrogen is there? CH3, 3 hydrogen. The in place of hydrogen means that hydrogen is replaced by a halogen atom. So what is X? X may be fluorine, bromine, iodine. So what is the formula of haloalkane? Now we will get haloalkane. So what is the formula for CH4? CH4 minus 1 hydrogen plus 1 halogen atom, let it Cl. So it will be CH3Cl. So like that, what I will do? C2H6, I will replace 1 hydrogen atom by another bromine atom. It will be C2H5Br. So these are the haloalkane. So next we will discuss classification of haloalkane. Classification of haloalkane. First, on the basis of number of halogen atom. How many halogen atom are there in the haloalkane? On that basis we will discuss. The first, if it contains 1 halogen atom, that is known as monohaloalkane. The first one is your monohaloalkane. What is monohaloalkane? If the halogen atom if the haloalkane contain only 1 halogen atom, for example CH3Cl, how many halogen atoms are there? Here this is the only 1 halogen atom. C2H5Br, how many halogen atoms are there? 1 halogen atom. C2H5I, how many halogen atom? 1 halogen atom. So like that, monohaloalkane means how many halogen atoms will be there? 1 halogen atom. Clear? Again, monohaloalkane further classified into 3 types. In this case, all carbon atom has sp3 hybridized. So again, monohaloalkane classified into 3 types. For example, CH3 CH2Br, CH3 CH3Br. One more example is CH3 CH3Br. See, in all these cases, this case and this case, 3 cases are there. So we have to identify these haloalkanes in the form of primary, secondary, tertiary. So to find the degree, there is a simple formula: degree equal to 3 minus n. So what is n? Where n equal to numbers of hydrogen atom, on the carbon containing halogen atom. What is n? Number of hydrogen atom on the carbon containing halogen atom. Now come to this case. This is the carbon which directly contain this halogen atom. So this carbon contain how many hydrogen? 2 hydrogen. Here n equal to how much? 2. N equal to how much? 2. So what is the degree in this case? Degree equal to 3 minus 2. That is your first degree, or primary alkyl halide. Come to this case. This is the carbon directly contain halogen atom. In this case, what is the n? N equal to how much? 1. N equal to how much? 1. So what is the degree? Again, degree formula is 3 minus n. 3 minus n, what is the n value? 3 minus 1, 2 degree. 2 degree means this is your secondary. What is the degree? Secondary alkyl halide. Now come to this case. This is the carbon directly contain this halogen atom. So what is the n value here? N equal to 0. So how many hydrogen are there? No hydrogen. N equal to 0. So what will be the degree? Degree equal to 3 minus 0. How much? Third degree. Third degree means tertiary alkyl halide. So again we can classify into primary, secondary, tertiary. So you can easily identify which one is primary, which one is secondary, which one is tertiary. Next type of haloalkane is your dihaloalkane. So dihaloalkane means how many halogen atoms will be there? Must contain 2 halogen atom. How many halogen atom? It must contain 2 halogen atom. So again it mainly divided into 2 types. Dihalogen divided into 2 types. One is your geminal halide. One is simple geminal. Another one is your vicinal. So what is geminal? In geminal halide, what happened? Both the halogen atom contained by a single carbon. Here vicinal, what happened? The 2 halogen atom are contained by the adjacent carbon, contained by the two adjacent carbon. Come to this case for geminal, if CH3 CH2 CH Cl Cl, this is the how many halogen atom? 2 halogen atom. So this is a dihaloalkane, 1 carbon atom contain both the halogen atoms. This is your geminal halide. In this case what happened? Here you check, these are the two adjacent carbon. This contain 1 halogen atom and this also contain 1 halogen atom. So if two adjacent carbon contain 1 halogen atom each, that is known as vicinal dihalide. Complete. Now come to trihaloalkane. All of you know what is trihaloalkane. If it is contain 3 halogen atom CHCl3 CHI3, its other name is also haloform. What is the other name? Haloform. That is iodoform. Iodoform term is there in organic chemistry. These are the iodoform. Chloroform, all of you know chloroform. Other name is haloform. So tetrahaloalkane means it contain all tetrahaloalkane. If it contain 4 halogen atom carbon tetrachloride, a very famous reagent, all of you know, carbon tetrachloride. This is a tetrahaloalkane. Clear? Now some more alkyl halide is the most important one is your allylic halide. Allylic halide. You have to understand this one. CH2 double bond CH2. Sorry. CH2 CH single bond CH2X. What is X? X is for halogen. This is for halogen. What happened? This carbon contain double bond and this carbon also contain double bond. Clear? This carbon is adjacent to carbon contain double bond. This carbon is adjacent to carbon contain double bond. This carbon contain double bond. If the carbon which is adjacent to carbon contain double bond is contain a halogen atom, is called allylic halide. For example, CH2 double bond CH2Cl. This is the halogen atom. Contained by this carbon, and this carbon is adjacent to carbon containing double bond. So this type of halide are known as allylic halide. Two more types is there. One is your vinylic halide. You have to remember this term, vinylic halide. What is vinylic halide? CH2 double bond CHX. In this case what happened? If halogen atom is directly attached to carbon containing double bond. This is the carbon directly contain double bond. This is your phenylic halide. Another one is your benzoic halide. Benzoic halide. In this case, what happened? This is the benzene ring. The benzene ring contain one CH2 group. If this CH2 group attach with a halogen atom, this is the example of benzoic halide. This is all about introduction of haloalkane. And let's introduce what is haloarene. So haloarene. So all of you know this is benzene ring. This is the benzene ring. So what happened? If benzene ring directly attached with a halogen atom or a halogen atom directly attached to benzene ring, that is known as haloarene. That is known as haloarene or aryl halide. Haloarene or aryl halide. Clear? Complete? One more example. This is also one example of aryl halide. This is also one example of aryl halide. Clear? So all of you know about nomenclature and isomerism in class 11th. In very shortcut, I will tell you nomenclature. Remember, in IUPAC nomenclature, what happened? This haloalkane are haloalkane nomenclature. For example, CH3, CH2, Cl. So this halogen atom is always treated as prefix. Clear? It has prefix. So if Cl is there, chloro, Br is there, bromo, like that. What is the position 1, 2? Already people are know. 1 chloro, ethane. All of you know rule of nomenclature. There will be hyphen between number and letter and comma between two number, etc. You go through the nomenclature in class 11. And isomerism, it will show two isomerism. So two isomerism. One is your chain isomerism. In short, I will tell you. Another one is your position isomerism. So chain isomerism, already class 11 people know what happened. There will be change in carbon skeleton. There will be no change in position of halogen atom. Here the carbon skeleton remains same and position of halogen atom change. For example, C4H9Br is the formula of a haloalkane. So first one, let's check CH3, CH2, 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 Br. So what will be its chain isomer? Chain isomer means this will always in the first position. So what will be change? CH3, CH, CH3, CH2, Br. This is, these two are what happen, chain isomer. And what are position isomer? These two are chain isomer. What about position isomer? CH3, CH2, 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 Br. The position isomer is, you have to change the position of halogen atom Br. Here it is in first position. If you change here, it will be in first, second position. If you put here, it will be again also second position. So this, and if you put Br here, these two are same. If I put Br here, this and this will be same. So only two position isomer will be possible. How many isomer? Two position isomer is possible. So these are the class 11 thing. So go through that. So haloalkane show two type of isomerism. One is your chain, another one is your position isomer. Next is very important, that is your preparation. Preparation of haloalkane. We will discuss one by one.